Hello everyone, I am Prashant Mahajan from All India Sri Shivaji Memorial Societies, Institute of Information Technology, Department of Electrical Engineering. In this video, we'll be looking at the instruction set of PIC microcontroller. So the instructions in PIC microcontroller are basically divided into 4 categories. First is byte oriented operations, second is bit oriented operations, then there are literal operations and control operations. So this video will be concentrating on the byte level operations, and we'll be seeing the various operands used in this instructions. So byte level operations, there are basically 3 operands which are used in these type of instructions. And the first operand is denoted by F, which is a file register. Second is denoted by a D, which is the destination of a result. And the third one is A, which is the access bank or the access bank. It could be an access bank or any other bank. So what F basically stands for is it gives you the lower 8 bits of address of the file register. D is the destination select bit. So if in an instruction, if you give D is equal to 0, then the result is stored in working register. And if you give D equal to 1, the result is stored in the file register. And A is the RAM access bit. So if you give A equal to 0, the RAM location is in access bank. And if A is equal to 1, the RAM bank is specified in or is specified by the bank select register. So we'll take an example of a byte oriented operation. The instructions that we'll be looking at is add instruction. So the instruction is add WF F comma D comma A. So this instruction will add the contents of a file register, and depending upon the values of D and A, the result will depending upon the values of D, the result will be stored either in working register or in file register. And now this file register, the location will be taken into consideration using the value of A as well. Okay. So this instruction add a WF will add the contents of working register and the contents of memory location whose address is 0x000, and the result will be stored in the working register. So this is for specific instructions that I have written: add WF 0x00, comma 0, comma 0. So we'll take a look at different combinations of D and A and how it affects the working of the instruction. So we'll assume that the contents of 000 location is 05H, 100 is 03H, 200 is 09H. So these are the assumptions which I have made before execution of a program, which you'll see in a moment. Okay, so if you see, this is a memory map which is given. The first one is the access bank. The access bank will start from 000 to 05F, and the second part is F60 to FFF. So these two parts will constitute what is called as an access bank. So in 000 we have assumed that the contents are 05. Over here we have assumed it as 05. Whatever I've shown over here is the complete RAM address. So it will start from 000, then and it will end to at FFF. So in between you will have a location 100 which has an content equal to 03 as shown over here, and a 200 location will have a content equal to 09. So these are the assumptions which I have made before executing of the following program. Okay, so this is the program which will be executed. What is been done over here is the bank is selected. Move LB0x02 will select bank 2, or rather basically the bank select register will be loaded by a data 0x02. Move LW0x01 will load 01 data into working register. Now add a WF 0x00, 0, will add the contents of memory location whose part address is 00H, and the complete address will be able to get using this operand, and you have to check the Axis Bank bit as well. So A is 0 over here, so you need to find out a location in Axis Bank whose last 8 bits are 00. So the complete address will be 000. So this instruction will add sorry, the contents of working register with contents of memory location 000, and as destination bit is 0, the result will be stored in working register. So the working register contains 01, 000 contains 05, so 5 plus 1 is 6, and this 06H will be loaded in working register. So working register will be equal to 06. 000, 100, 200 will continue to hold the values which were previously stored in those particular memory locations. So 000 will have 05, 100 will be 03, and 200 will be equal to 09. So we'll consider a case now where these two bits are 01, which is the next program that we'll be considering. Rest the complete program will remain same. Okay, so everything is same. Now the add instruction will have destination bit equal to 0. So the result will be stored in 0, but now the access bit A bit is equal to 1. That means the memory location now will be changed if you compare it with the previous example. Now what this instruction does is that it will add the contents of a memory location. Now this is a part address. Now the complete address will be obtained by this part address F, and the first 4 bits will be taken from bank select register as A equal to 1. So bank select register is equal to 2, therefore the complete address will be equal to 200, right? So this instruction will add the contents of working register with contents of a memory location 200, and the result will be stored in working register. So the contents of working register are 0, 1. The contents of a memory location 200, if you see, are 09. So 09 plus 01 is 0A. That will be stored in the working register. Rest all the contents will remain same. So a working register is 0A. 000 will be 05, 100 is 03, and 200 will be equal to 09. So this is the second combination that we have taken into consideration. Now we'll take the next one when the bits are 1 0, D is equal to 1 and A is equal to 0. Okay, so this is the example. Now in this case, again bank 2 is selected, working register is 0 1, and this now the add instruction, add WF 0x00, 1, 0 will add the contents of working register with a memory location 000, okay, because Axis Bank is selected, and the result will be stored in the file register. Okay, so which is a file register which in consideration, the file register in consideration is 000. So after addition, the result will be stored in a memory location 000. Okay, so before the addition is being done, the contents of 000 are 05. The contents of working register are 01. So 05 plus 01 is 06, and the result will be stored in the file register, which is 000. So 05, which were the initial contents, will now get changed to 06. The working register will contain 01, and 100, 200 will continue to hold the original values. So W equal to WREG is equal to 01. 000 will be equal to 06. 100 is 03, and 200 is 09. Okay, so if you can see 000, which initially contained 05, will now contain 06. So this is the next combination, and then we'll take a look at the last combination wherein D is equal to 1 and A is also equal to 1. Now in this combination or in this instruction, the memory location which will be under consideration will be 200, because the lower 8 bits are 00, and the upper 4 bits will be given by the bank select register. Okay, so bank select register is holding 2, so the complete memory location address will be 200. So this instruction will add the contents of working register and the contents of 200, and the result will be stored in a location 200. Okay, because destination bit is equal to 1. So if you consider that working register is containing 01, memory location 200 is containing 09. So 01 plus 09 is 0A, and the result now will be stored at the file register, because D is equal to 1. If D would have been equal to 0, it would have been stored in working register. So the memory at which the result will be stored is 200. So okay, so this content will be overwritten. Rest cells will remain the same. So working register will be equal to 01. 000 will be equal to 06. Okay, so this was the previous value which was there, and then I've not changed this to 06 in this slide. Anyway, 100 will be equal to 03 as it is, and 200 it will now get changed to 0A. Okay, so this is how the instruction works. So this is as far as the byte level operations are concerned. In next videos, we will take a look at the bit level operations. Thank you.